Good evening, everyone. Welcome to the class on transportation problem for a subject called operation research. So, guys, in this class, there's a data is given, which we are going to solve this problem of transportation. So here, data is given about supply and demand, and the cost matrix is given. We need to find the optimal solution under the given scenario. So, if you see, the first thing what you need to do, you need to make sure that the total sum of supply should be equal to the total sum of demand. So make sure that happens, that the total sum of supply is equal to total sum of demand. So, so if you see the total sum of supply and demand, so the total sum of supply, this is 34 plus 15. So we can do 34 plus 15 plus 12 plus 19, 9 plus 2, 11. Okay, yeah, it's given only 80 both the sides, right? So I don't think we need to do that because that part is given to us. It's already given in the problem only. So no need to do that. So two things you need to do whenever you see the transportation problem. First thing is that the element what is given should be cost element. The objective should always be minimum, and then the total sum of supply should be equal to total sum of demand. Both is given, and this is the data given. So they have not mentioned in the problem by using which method you can determine the initial basic feasible solution. So you can use any method. Let me use what like let me use northwest corner method. With that, I'll find the initial basic feasible solution. So once I'll find the initial basic feasible solution by northwest corner method, then what I'll do? Once I'll do that work, then I'll do the test of optimality on those values. So when we work on the test of optimality on those values, we'll do that. So here if you see northwest corner method, so I'll start with the first cell, which is a northwest cell. So you can see the demand is 21, the supply is 34. So you can put 21 here. So if you put 21 here, so this demand is done. This demand is done. So the supply left is 13. So this now if you see this is for the second element, the capacity is 13, demand is 25. So you can write 13 here. So this will be done. This will be 12. Then you can put here 12. Here 12 and this here left only 3. So the advantage what we get by using northwest corner method is that you can do it fast. Determination of initial basic feasible solution, you can do it fast. Although then optimality would be big headache. So here if you see that here capacity is 3 and then the demand is 17. So I can put 3 will be 14. So here you can put 12. This will be 2. So here you will put 2. This becomes 17. 17 will put here. So with this, what you can do, you can check the total allocation. Total allocation from which 1, 2, 3, 4, 5, 6, 7. Total allocation is 7. And if you see the total row is 4, total column is 4, then the total allocation should be 7. So here also you have 1, 2, 3, 4, 5, 6, 7. So I think this is done. But we can find the total cost here. We can find the total cost here, but that is not required till the time we don't know the solution is optimal or not. So let me just write down the whatever solution we get. Then we'll do the test of optimality here. So one allocation is 21. Then 5 allocation is 13. Then 3, 3. Then we have 3. Then we have then you have the 0, 3, 0, 3, 12, 0, then 3, 12, then 1, 3, then 1, 3, then 2. Then next one is 0 2 2 0 2. Next to the third 2, the 0 2 2, the third 2 is 12. Allocation is 12, 0 2 2 and 3. Then it is 2 7 2 2. 2 7 2 2 2 7 2 2 2 7 2 2 7, then 2 7 2 2 4 17 4 17 2 7 2 2 and then 4 17. Yeah, so this is what we got. This is the allocation what we got here. Fine. So now we need to know this allocation what we did is optimal or not. So for that, what we'll write u1, then u2, then u3, then u4, then v1, then v2, then v3, then v4. Fine. So we'll write this, and then what to do? You see which row or column has maximum allocation. 2 2 1 2, then 1 2 3. So you can see maximum allocation in third column. So you can put the value 0 for that. So guys, just focus on those cells which are allocated. Just focus on those cells which are allocated. Focus on those cells which are allocated. So just focus on those cells which are allocated here. Focus on those cells which are allocated. Focus on those cells which are allocated here. So if this V3 is 0, right? So what you need to do here, you should focus on those cells which are allocated. Then for occupied cells, use the formula Cij is equal to Ui plus Vj for occupied cell. So you know their cost and all, right? Ui Vj is one element you have to put 0. So U2 you will get 1, U3 you will get 2, U4 you will get 2. Fine. Then U4 you will get 2. So I can find V4. V4 will be 2. Because the cost there is 4. No? You can understand. That is U4 plus V4. So U4 is 2. 4 would be also 2. I hope you understand. So like this, you can find all the elements. Like this, you can find all the elements. Okay, so you can find all the elements u1, u2, u3, u4. Just use the formula Cij is equal to ui plus vj. Okay, then I can find this is 1, this is 2, this is 2, this will be 3, this will be 3, and then this will be minus 2. So the first element C11, the cost is 1, then UI is 3 and V1 is 2. 3 minus 2. I hope you got it. Now, so by using the occupied cell and the formula Cij is equal to Ui plus Vj, you can find all these values U1, U2, U3, U4, V1, V2, V3, V4. Now for unoccupied cell, now for occupied cells. Now for the unoccupied cells, use the formula Cij minus Ui plus Vj. Okay, so you have to use unoccupied cell. Now you have to run for unoccupied cells. So for unoccupied cells, use this formula. So you can use the formula that here A13 the cost is A13 the cost is 3 and this is A13 The cost is 3 and U1 is 3 and V3 is 0. So 3 minus 3 plus 0, the answer was 0. Then you see this set the A14, the 3 minus 3 plus 2. It means minus 2 will get no here, you will get minus 2 here. Okay, then you remember that because that shows is not appropriately allocated, then this is minus 2 plus 1 minus 1 0 minus minus 1 that you get plus this 2 plus 1 is 3. So 2 minus 3, this will be minus 1. Okay, then the third A31, the third row first column, that is 0. So 2 minus 2, that is 0, 0 minus 0 is 0. Then this is 2 plus 2, 4. This you'll get minus 2. Okay, then this is 4. 2 plus 2, 4. Then you'll get minus 1. Then here this is 4 positive, this is 0 positive. So now only you are getting out negative value. You can see you are getting in which cell. You can see in which cell you are getting negative value, and like this cell is a negative value. Then this cell is a negative value. Then this cell is negative. This cell is negative. So this shows inappropriate allocation, means whatever allocation we did is not up to the mark. So we need to reallocate everything. So for that we'll draw looping. We'll do looping. We'll take the help of looping to do that. So out of this maximum negative, you can either go to A32 or A14 because both are having same element of that minus 2 is the negative allocation. So out of that 3 and 2, you can do on any one. You can do on any element. So imagine if I do on this element. Just suppose if you do this, you have to draw a loop. Okay, and you put plus sign here. This will be minus sign. Then this will be plus sign, and then this will be minus sign. You have to draw the loop, and now if you draw the loop, so whichever negative you call that theta. This one, the first is theta, second one will be 12 minus theta, the third one will be 3 plus theta, the fourth one will be again 12 minus theta. So you, out of the negative coefficient before the theta value, if you see, we'll try to find out where we get the minimum theta. So the minimum theta value is 12. This will be 0, and then this will be 15. This will be again 0. And theta value will be 12. So this is how we do the allocation. So here, if we do the allocation, if you do the allocation here, if you do the allocation here, then this is 121, 530, 121, then 530, 121, 513, 3, 3, 3, then you have 3, 3. Then 0, then you have 0, then you have value 0, then you have 3, then you have 3, then the allocation becomes 0, the 12 minus theta, then 3, then the cost of this is how much? Cost of third element is how much? 0, 0, 3, 1. That 1, the allocation was 3, 3, 3, 1. No, no, no. 1302. This is 1302. This is 1 minute. 1533. Then 3312. Then 0223. Then 2724. So this is guys 3. This is actually 3. Okay, I hope so. It does not created any impact. This the second one is actually 3. This value is actually 3. Remember that. So if you do allocation here, so if you do the allocation here, this is 3. So this is 3, that this becomes 0, then 3, then the third element was 1. So the 1 have which would had the allocation 3, it will become 15, then 2, 1, then this is 2, 1, and then 3, 2 rows done, then third row is 0, 2, 2, 3, 0, 2, 2, 3, 0, 2, 2, 3, 0, 2, 2, 3, 0, 2, 2, 3, okay, then 2, 7, 2, 4, 2, 7, 2, 4, 2, 7, 2, 4. So this is 21, 13, this is 15, then 2, then this is 0, 2, 2, 0, 2, the allocation should be 12, 0, 2, 0, 2, the allocation should be 12, 2, the allocation should be 12, and this would be 2, this will again 0, 2, 12, then this 2, 12 allocation gone, then 3, then this is 2, 7, 2, 7, 2, 2 allocation, and 4, 17. So you will get U1, you will get U2, then you will get U3, then you will get U4, then you will do V1, then V2, then you will do V3, then you will do V4. Okay. Then everyone, so this U1, if that allocation we did, okay, I know that this is not a optimal, what to say, non-degenerate allocation. It is not, the allocation is not non-degenerate, because you know the 2 element becomes 0, 0. But definitely here we need to put epsilon. I hope you remember last class I discussed about putting epsilon. So if the total number allocation does not follow n plus n minus 1, then we left with no option, we have to put epsilon. So we'll see where we can put epsilon. Let u1 is 0, so this will be equal to 1, this will be equal to 5. Okay, so you know that, right? You know the, I for the last, I have discussed this, that for occupied cell, what we do for occupied cell, our formula is Cij equal to ui plus vj. We'll use that formula. Occupied cell. So with this formula, we'll find the value u1, u2, u3, u4, v1, v2, v3, v4. So I got without with that, you know that a11 the cost is 1, u1 is 0, v1 is 1. Okay, this is 5, this is 0. And then this is the cost is 2, the cost is 2, ui u3 plus v2 v3 plus v2 equal to. Clear, right? So here you will not get the all the u1, u2, u3, u4, v1, v2, v3, v4 filled values. Why you will not get? Because you know that the total number allocation is not following m plus n minus 1 rule. So here one value you will put epsilon. So which value you should have to put epsilon for that? see all the non-allocated values, see which is the having the least value. Okay, and make sure that it should not impact your solution. Okay, you have to make sure that it does not impact your solution. So if I put epsilon 0, for example, we try to put a negative value, so then you can see, then on that case, you can see here, if I put epsilon on 0, you can see here u3 is minus 3 and v1 is 1. So the Cij is equal to ui plus vj. Cij is 0 and ui is minus 3, v1 is 0. Minus 3 plus 1, then it will be minus 2. So it means this is wrong. So here I cannot put epsilon because it is not satisfying the rule that Cij is equal to ui plus vj. Okay, so where I can put minimum value, let I put here. So if I put here, you can see this, see the allocation. Allocation, then this should be 1. And this is 1, then it should be 1, this should be equal to 3. And then this should be equal to 0. Let me just see that it should not impact, just focus on occupied cell. So A11, correct. Then the A125, then A23 you understood 1 and 0. Then A32 is 5 minus 3 2, correct. Then A41 is 1 plus 1 2, correct. 1 plus 1 2, correct. Then 3 plus 1 4, correct. So you can see all the occupied cell allocation. Here, so we'll do for occupied cell, and once we do for occupied cell, we found the allocation. We have to put epsilon on that value so that it should not impacted the total allocation whatever done for so far. So that it should follow the formula Cij is equal to ui plus vj, and for unoccupied cell, well, for the unoccupied cell, we use a formula for Cij minus ui plus vj. So these are unoccupied cell, guys. So now for the unoccupied cell, you see A13, correct, positive you are getting. A14, 3 minus 3, 0, correct. Then A21, correct, 3 minus 1. Then A22, 5, you are getting negative here. So this is 5 minus 2. This is minus 2. Then this is 3, this is minus 1. Then this is minus 2, 0 minus minus 0, 0, then minus 3 plus 1, minus minus plus, then 2 minus 3 plus 1 is minus 2, 2 minus minus 2, 4, 3 minus 3, 0, 3 minus 0, then 7 plus 1, 6, 7, 5 plus 1, 6, so 7 minus 6, 1. You can see this is the allocation what you get for the unoccupied cell. Tell me if you have any doubt. Now here, if you see out of this allocation, do you get all positive value? You can see the unoccupied cell. So that is A13 is positive, A14 is 0. So then 2A21 is 2, A21 is 3 minus 1, then this is minus 2, okay, then this is minus 1. Fine, then this is 0 minus minus 3 plus 1, 0 minus minus 2, then minus 1 plus 3 minus 2, 2 minus minus 2, minus 2 minus 3 plus 2. So you can see here, you still the solution is not optimal solution because still you are getting negative value. So first, by using Cij is equal to ui plus bj, we work on occupied cell and find the value of u1, u2, u3, u4, v1, v2, v3, v4. Then what can be done? So then probably we'll see how we can make sure that the final allocation by working on unoccupied cell should be positive. So you can see this is negative. So you can create a loop, guys. You can create a loop here. So you can create a loop here. You can create a loop here. The loop should start from here and should end there. You can create a loop here. The loop, in our loop, the loop should start from here. Okay, and then we need to see how the loop construction can be done. It should move only on occupied cell. If you try to construct a loop, guys, only on occupied cell you can move loop. So, so how can I create a loop? You can see this. This I can create a loop. This is plus sign minus 1 plus 1 minus 1 plus 1 minus 1. Once you're done with this, so then whatever the value, whichever the cell having negative value, we'll call this as theta. Another one, this would be 13 minus theta. Okay, 13 allocation. This would be no, very wrong. The million occupied cell allocation should be 'So I have to move volume on this empty cell, allocated cell. Yes. One minute here. This 2 was epsilon, right? So 121, 513. Then this is 3, 121, 513. Now you have omni allocation. 7 it should be 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 1, 2, 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7. If I move here, I can move here, then I can move here, then here, then here, then here. I can move here, then here, then here, then here, then here, and then here. This I can do, guys. Okay, so this is plus 1, then minus 1, then plus 1, then minus 1, then plus 1, then minus 1. You understood, right? So, so what you can do here, so you can write this as theta. The unoccupied cell is theta. The unoccupied cell you can write theta, that which having -2 allocation. The next one is 13 minus theta. Okay, then you have allocation is 21, 21 plus theta. Then you have epsilon minus theta. Okay, then you have 2 plus theta, and then you have 15 minus theta. So 0, 30 minus theta, 21 plus theta, then epsilon minus theta, 2 plus theta, then 15 minus theta. Now out of, just focus on negative values, negative theta value, see which is negative, least one will be epsilon. So theta is equal to epsilon, this will be 13 minus epsilon, this will be 21 plus epsilon, this will be 0, this will be 2 plus epsilon, this will be 15 minus epsilon. Here everyone, so this would be allocation now. Now your allocation would be this one. Anyone, any doubt? Okay, thank you, Lakshmi. So just purposefully I have taken this question. This is difficult question. So purposefully I have taken the difficult question because looping would be the important concept what you need to understand. In internal exam, till transportation problem, everything you have to study. Okay, so now if you see this, so this is one. Now if you see this, let me just simply write down the element first. 1, then 1, 5, then you have 3, then you have 4, 1, 5, 3, 3, 4. Then you have 3, 3, 1, 2. Then you have 0, 2. Then you have 2, 7. Then 2, 4. And the allocation will be for 1, your allocation that is 21 plus epsilon. This would be 21 plus epsilon. Second one, that is 13 minus epsilon. Second one will be 13 minus epsilon. Okay. Third one, third cell nothing, fourth cell nothing, then nothing. Then this will be 15 minus epsilon. This will be third one, third one, 15 minus epsilon. This will be 15 minus epsilon. Okay, and you started from this, no, this cell. This cell would be epsilon 3. This 3, it would be better if you have put 3 epsilon instead of 2. Then 2, that is -1, unoccupied cell. Then 2, 12. Then this 2 is 12. So allocation is 12. Then this 2, that epsilon gone. Then third 2 become 2 plus epsilon. Third 2 means 2 plus epsilon. Then 4, that value 17. Allocation is 17. So this is the new allocation. I don't know this is ideal or not. So for that we'll write U1, U2, U4, then V1, V2, V3, V4, So if I put 0 because the maximum location in second column, so then this would be again I use the same formula, guys. For occupied cell, I told you, right? Every time I'm not writing the same thing. For occupied cell, use the formula. For occupied cell, use the formula called Cij is equal to Ui plus Vj. So this would be 0. So Cij here would be C cost is 5. Here cost is 3. Here the cost is 2. Okay. Okay. Fine. Then you can find V1. This is cost is 1. This is 5. So 1 is equal to 5 plus x. This will be minus 4. This is minus 4. Then this is cost is 1. This is 3 minus 2. Then okay. Then this is 2 is equal to u4 plus minus 2. Then it becomes 4. This becomes 4. This becomes 4, and this value is 417. 417. This is u0. So you can see this. Your allocation, you can see this. And now I'll find for unoccupied cell. What are your unoccupied cell? Now your unoccupied cell. So what are your unoccupied cells? For your unoccupied cells, whatever your unoccupied cell, for your unoccupied cell, what I'll do is for your unoccupied cell, I use a formula for unoccupied cell. Cij minus ui plus bj. So this is minus 2. This is 5. 5 minus 2, 3. 3 minus 3, 0. This is 5 minus 3 minus 5. This is minus 2. Still negative is there. This is minus 1. Then this is positive. Then this is 2 minus 2, 0. 2, 2 minus 0, 0. Okay. Then this is minus 5 minus 4 plus 2 minus 2. 0 minus minus 2 positive. This is 0 cancel. This is 7 positive. Okay, so you can see now if you see the negative value, the most negative value is A14. So our we'll start our looping from here, and from here we'll go to occupied cell only. Looping can only done on occupied cell. So you can see this I can do 1 minute.